Hey there guys, welcome to my walkthrough of the June 2017 Edexcel GCSE Maths Paper 1. So it's a non-calc paper, part of my playlist containing every Edexcel higher past paper, which you can get down below in the description. There's also lots and lots of useful content down there to help with your GCSE Maths revision. Highly recommend checking it out. Okay, let's do this. Okay, question 1. The scatter graph shows the maximum temperature and number of hours of sunshine in 14 British towns on the same day. So we got max temp going up the side, hours of sunshine along the bottom. Part A tells us that one of the points is an outlier. Write down the coordinates of this point. Okay, so an outlier is a point that doesn't fit with the rest of the data. So it's definitely this guy. Now if we go straight down, we can see its x-coordinate would be there, which is 10, and its y-coordinate there, so that's 19. So it's 10, 19. So far, so good. Part B asks us to, for all the other points, write down the type of correlation. So, we can see, as the number of hours of sunshine increases, in general, so too does the max temperature. So, when both things increase, this is positive correlation. Negative looks something like that, where as one thing increases, the other decreases. Cool. Part C. On the same day, in another British town, the max temperature was 16.4 degrees. Estimate the number of hours of sunshine in this town on this day. Okay, so we're going to use the graph to do this, and what we need to do is use a line of best fit. So that's going to look something like that. I'd say that looks pretty good. So what we then do is we find 16.4 degrees. Make sure you're happy with the scale. That would be 17. Every little square is worth 0.2. So 16.4 is there. Go across till we hit the line. Just gonna be about there, and then go down. So again, that'll be 12. So every little square is worth 0.2. We're coming down to about there. That's gonna be about 12.8. Part D. A weatherman says temperatures are higher on days where there is more sunshine. Does the scatter graph support what the weatherman says? Give a reason for your answer. So we've sort of already covered this in the type of correlation. So looking back at the graph, we can see that other than the outlier, maximum temperatures are a lot higher when there is more sunshine. So the answer is yes. And we should say something like the graph shows higher temperatures as a number of hours of sunshine increase, except for the outlier. Go. Question 2 wants us to express 56 as a product of prime factors. So that means factor trees. So we write down 56 at the top. Now we try and think of a prime number that goes into 56. 2. Circle 2 because it's prime. Now the other number then, that we write on the other branch, it's 56 divided by 2, which might be a bit tricky, so we'll use the bus stop. So 2 into 5 goes twice, remainder 1, 2 into 16 goes 8 times. Now 28 is not prime, so now we do the same. So again, as a factor of 2, and 14. 14 is not prime. 14 is 2 times 7. Both of those are prime, so our adventure is over. 56 is 2 times 2 times 2 times 7, which we can sharpen up as 2 cubed times 7. Cool. Okay, question 3 wants us to work out 54.6 times 4.3. So, with multiplication, so many different methods. When it comes to, in particular, decimals, I recommend the Lattice Method. So, if you've not seen this before, it's worth checking out. So, at first, we're not even going to worry about the decimals. We're just going to think about doing 54.6 times 4.3. So we need a 3 by 2 grid. Doesn't have to be perfect, luckily. Now what we do is put diagonal lines from bottom left to top right of each box. Okay, so we're going to put 54 and the 6 at the end. So there is a decimal, obviously, but we're not worried about it yet. And then 4.3 down the side. Now what we do is multiply the side and the top together in each box. So 4 times 6 is 24. 4 times 4, 16. 4 times 5, 20. Second row, 6 times 3, 18. 3 times 4, 12. And 3 times 5 on a good day is 15. Okay, so what we now do is we add up along each of these diagonals. And it's really important that we start with the bottom right. So this first one is easy, it's just 8. So we got 4, add 1, add 2, which is 7. And then we've got 2, add 6, add 1, which is 9, add 5 is 14. So, just like when you're doing normal addition, if you get a 2-digit number, you carry the 10 to the next row or column. So we're going to put a 4 here, and then we're going to carry 1 into the next diagonal. So then we got 1, add 1, add 0, add 1 is 3, and then 2 just falls out. So what do we then do with the decimals? Well, imagine this top one, it's cruising down there, the one on the side, it's cruising across. The point where they meet, they then roll out on that line. And the decimal goes there. So our answer is 234.78. Cool. Okay, question 4 for 3 marks. We have this square, and we are told the area of the square ABCD is 10 centimeters squared. We want to show that x squared add 6x is equal to 1. So, how in the world do we do this? Well, we take a closer look at this square. So the square is made up of this 3x3 square. 2 rectangles are going to be the same. So the length of this rectangle is 3 because it's directly below there, so 3 centimeters. Same with this rectangle over here. The height of this guy is 3. And then we got this little square down here, which has sides of x. Yep. Okay, so well, what we can do here is work out the areas of each part of this square. So the bottom bit is x squared, the rectangles are 3x and the big square is 3 times 3, which is 9. Now we know the total area of ABCD is 10. So we know that x squared add 3x add 3x add 9 is equal to 10. Now that means then that x squared add 6x add 9 is equal to 10. Take away the 9 and x squared add 6x does indeed equal 1. Boom. Okay, question 5, the first 5 marker. So we got a rectangular metal frame made from 5 straight pieces of metal. We're told the weight of the metal is 1.5 kilograms per meter. Work out the total weight of the frame. Okay, so to be able to work out the total weight, we need to know the total length of metal used in the frame. So, we already know most of that. We know because this is a rectangle, this side is also 5, and this side is also 12. Now, what we need to work out is the length of the diagonal bit. So, being the diagonal of a rectangle also makes it the hypotenuse of a right-angled triangle. So, Pythagoras. Now, if you haven't already, check out my formulas video, which is down below, where you can also get a printable PDF copy of every formula that you need to know. So Pythagoras tells us if that's A and that's B and that's C, A squared add B squared is equal to C squared. So from that, we know then that 12 squared add 5 squared, we'll call it x, so 12 squared add 5 squared is equal to x squared. 12 squared is 144. 5 squared is 25. Add those two together and you get 169 is equal to x squared. Square root both sides. X is equal to 13 meters. So now we can work out the total length. So we got 2 times 12, which is 24. And 2 times 5, which is 10. And then our 13. So that is 34 add 13 is 47. So 47 meters. Now the total weight is, well, we know that every 1 meter weighs 1.5 kilograms. So it's 47 times 1.5 kilograms. Now, 1 times 47 is 47. 0.5 times 47 is just half of 47, which is 23.5. So the total weight is 47 add 23.5, which is 70.5 kilograms. Cool. Okay, question 6, 2 marks. The equation of line L1 is y is 3x minus 2. The equation of the line L2 is 3y minus 9x add 5 is equal to 0. We want to show that these two lines are parallel. So if two lines are parallel, it means they have the same gradient. Now, remember the general equation of a straight line. Y is equal to mx add c. M is the gradient and c is the y-intercept. Now to read gradient lines have to be in this form. Equations have to be in this form. So from this, we already know then the gradient of L1 is 3. So, what we need to do is rearrange L2 and hope that we get 3 for the gradient. So, as it stands, we have 3y minus 9x at 5 is equal to 0. That's the worst colour in the world. Okay, so we need to make y the subject. So let's add 9x. So 3y add 5 is equal to 9x. Now we need to move the 5, so to subtract that. 3y is 9x minus 5. Now to get rid of the 3, divide both sides by 3. We get y is 3x minus 5 over 3. Now the gradient of L2 then is also 3. So L1 and L2 have the same gradient. So parallel. Cool. Okay, question 7, we have reverse mean. So I've got a few videos on this, they will be down below. So, there are 10 boys and 20 girls in a class. The class has a test. The mean mark for the whole class is 60. The mean mark for the girls is 54. Work out the mean mark for the boys. Okay, So, the gist of reverse mean is that to work out a mean, you do the total divided by the frequency. So here we are starting off knowing some means, knowing some frequencies, but we don't know anything about the totals. So here the totals would be the total marks. So what we can do then is get the mean times frequency is equal to total marks. So, first up, for the whole class, well, altogether there are 30 students, so the frequency is equal to 30. Now we know the mean is 60. So we can say the total marks is equal to 30 times 60. Now, 3 times 60 is 180. We then need to multiply that by 10. So we get 1,800. So we now know the total marks achieved by the whole class. What we can now do is exactly that for the girls. And then when we know the total marks scored by the girls, we can then take that away from the total for the class, work out the total for the boys, and then get the mean. So, for the girls, frequency is 20, mean is 54. So, we know their total is 20 times 54. Now again, we can split that. 2 times 54 is 108. 108 times 10 is 1080. So, now we can work out the total score for the boys. It's the total of the class, which is 1800, minus the total of the girls, so 1080. And that gives us 720. So their mean is 720 over 10, which is 72. Cool. Okay, question 8, we have standard form. So, part A wants us to write 7.97 times 10 to the minus 6 as an ordinary number. So, the power of minus 6 tells us that the decimal point goes 6 places left. So, it's going to go 1 place left to cover the 7. So we're going to have 7, 9, 7. Now it needs to go, once it's moved 1 place, it now needs to move 5 more places. So we need 5 zeros. So it's 0.000000797. Cool. Part B answers to work out the value of 2.52 times 10 to the 5 divided by 4 times 10 to the minus 3, giving our answer in standard form. So, first up, think of this division as a fraction. So we've got 2.52 times 10 to the power of 5 over 4 times 10 to the minus 3. Okay, now from here, think about how we multiply fractions together. We do the top times the top and the bottom times the bottom. So we can do that in reverse to split this fraction. So we can say we've got 2.52 over 4 times 10 to the 5 over 10 to the minus 3. So 2.52 divided by 4. Well, let's think about it. That's 2.52 divided by 2 and then divided by 2 again. So half of 2.52 is 1.26. Half of that is 0.63. Now, 10 to the 5 over 10 to the minus 3, in terms of the indices, we are doing a division, so we get 10 to the power 5 minus 3. So that's 10 to the power of 8. Now that is almost there, except with standard form, you are not allowed a 0 up front. So, what we need to do is multiply 0.63 by 10 to get 6.3. Now to cancel that out, we divide 10 to the 8 by 10. So we get 6.3 times 10 to the 7. Cool. Okay, number 9. Jules buys a washing machine. Really exciting, as always. 20% VAT is added on to the cost of the washing machine. Jules then pays £600. Our job is to work out the cost of the washing machine with no VAT added. So, this is reverse percentages. My videos are down below. Okay, so Jules. So we pay 100% of the cost of the washing machine, and then the VAT is 20% of the cost of the washing machine. So we're paying 100% of the cost of the washing machine, add 20%. So that means that 120% of the original cost is £600. Now, we want to find 100% of the original cost. So we need to try and think of a percentage that fits nicely into 120 and 100. So we're then going to divide down to that percentage, then multiply up to 100%. So the one that springs to mind for me would be 20%. So 20% is, well, we're dividing 120 by 6, so we divide 600 by 6. So 20% would be 100. So then 100%. So for that, we're multiplying 20% by 5. 5 times 100 on a good day is £500. Cool. Okay, number 10 wants us to show that x add 1 times x add 2 times x add 3 can be expressed in the form ax cubed add bx squared add cx add d, where a, b, c and d are positive integers. So, positive whole numbers. Okay, so the trick to triple bracket expansion is don't do triple bracket expansion. Multiply two of the brackets first, and then whatever that is, multiply by the third. So, let's multiply x add 1 by x add 2, first of all. So, make sure that you can get x squared add 3x add 2. So, we've now got x squared add 3x add 2 times x add 3. Now, I would highly recommend using a table in this situation. So, it's going to be a 3 by 2 table. So, we're going to put the quadratic across the top. So, x squared 3x and 2, and then down the side x and 3. So now each box of the table is a multiplication between the thing on the side and the thing on top. So x times x squared is x cubed. 3 times x squared is 3x squared. X times 3x, 3x squared. 3x times 3, 9x. X times 2 is 2x. And then 2 times 3 is 6. Okay. So, using the table guarantees that we don't miss any multiplications. So, that's the way I recommend. So we now need to bring stuff out and simplify. So we've got 1x cubed. We've got 3x squared and 3x squared. That's 6x squared. We've got 9x and 2x, which is 11x. And then at the end, we've got plus 6. Cool. Okay, number 11, we have a quadratic graph y equals f of x. And part A asks us to write down the coordinates of the turning point. So, a turning point, funnily enough, is where a graph turns around. So, here, it's this point. Now the x-coordinate is 1 and the y-coordinate is -3. So it's 1 -3. Part B. Write down estimates for the roots of f of x is equal to 0. So when you are solving a line or a curve equal to 0, you are finding the points where it crosses the x-axis. So we got 2 here, we got this guy. Now make sure you're happy with the scale. Every little square is 0.1, so this would be minus 0.75, and then the other one, this guy here, so that's about 2.75. Cool. And then part C wants us to use the graph to find an estimate for f of 1.5. So that means we want to find the value of the function when x is 1.5. So find 1.5 on the x-axis, which is there, and then go down until we hit the curve. So that's there, and then we want the value. So that's going to be minus 2.8. Cool. Okay, number 12, we have indices. Got a massive playlist on these down below. So we got two markers. Part A wants us to find the value of 81 to the minus 1/2. Okay, so there is 2 parts to this power. So if we first of all take care of the negative part, negative powers, or the negative part of a power, puts the number and the rest of the power on the bottom of a fraction. So 81 to the minus half is 1 over 81 to the half. Now, when you've got a power of a half, that means the square root. So the square root of 81 is 9. So our answer is 1 over 9. Part B wants to find the value of 64 over 125 to the power of 2/3. So when you got a power like this, what we're going to do, we're going to split it up. So we are going to say that this is 64 over 125 to the power of 1/3, all squared. By the rules of indices, when they are separated by a bracket, they multiply together, so we haven't done anything naughty, we've just split power. Now the reason we've split it is because each bit of the fraction does something different. So the bottom number are roots, and then the top number is the power that we raise things to. So 64 over 125 to the power of a third. Well, a power of a third means a cube root. So we cube root the top and the bottom. So the cube root of 64 is 4. And the cube root of 125 is 5. So we've now got 4/5 squared. So now we square the top and the bottom, so we get 16 over 25. Cool. Okay, number 14. So everyone loves ratio. When I say love, I mean hate. So this question, yay. So white shapes and black shapes are used in a game. Some of the shapes are circles, the rest of the shapes are squares. The ratio of white to black shapes is 3 to 7. So I'm going to write that down. Okay. The ratio of the number of white circles to white squares is 4 to 5. And the ratio of the number of black circles to black squares is 2 to 5. Okay, our mission, whether or not we choose to accept it, is to work out what fraction of all the shapes are circles. Okay, so lots of processing to do here. Let's first of all play with this first ratio. So white to black shapes are in the ratio 3 to 7. Altogether, this ratio has 10 parts, so we can say that 3/10 are white and 7/10 are black. Okay, on to the next one. So remember, we're only interested in circles. So we know that white circles to white squares are in the ratio 4 to 5. Altogether, this has 9 parts. 4/9 of those are circles. So 4/9 of the white shapes are circles. Now, what we can do from that is work out what fraction of all the shapes are white circles. So we know that of all the white shapes, 4/9 are circles, and we know that of all the shapes, the white ones make up 3/10. So white circles are 4/9 of 3/10. Now, when you're doing percentages or fractions and the word of pops up, think of it as a multiplication. So, 4/9 of 3/10 is 4/9 times 3/10. So, 4 times 3 is 12. 9 times 10 is 90. This simplifies to 4/30 or 2/15. So we now know that of all the shapes, 2/15 of them are white circles. So now we're going to do the same for the black circle, the black shapes. So altogether, the black ratio has 7 parts. 2 of those parts are black circles. So 2/7 of all black shapes are circles. So, as a fraction of all the shapes, black circles are 2/7 of the overall fraction of black shapes, which is 7/10. So that's 14/70 or 2/10. So overall, circles make up 2/10 and 2/15. Now if we go for common denominators, the lowest one is 30, so 2/10 is 6/30. 2/15 is 4/30. That gives us 10/30, which finally is 1/3. Cool. Okay, number 15, we got some approximations. So we are told a cone has a volume of 98 centimeters cubed. The radius of the cone is 5.13 centimeters. We want to work out an estimate for the height h of the cone, and we're given the formula volume is 1/3 pi r squared h. So we can't really do this, or we can't do it exactly without a calculator. So we're going to approximate. So what can we round 98 to for the volume? Let's go 100. The radius 5.13. We'll round to 5, and also we're going to need to round pi. So pi is 3.14159265378, blah 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 blah. Let's round it to 3. So pi these rounded numbers, we get the volume, which is 100, is equal to 1/3 times 3 times 5 squared times h. Now, that's going to give us 100 is equal to 1/3. Now, inside the brackets, 5 squared is 25, times by 3 is 75, so we get 75h. Now, when you multiply something by a third, you're just dividing it by 3. So 75 divided by 3 is 25, so 100 is 25h. So h is approximately, divide through by 25, we get 4 centimeters. Cool. For part B, John uses a calculator to work out the height of the cone to 2 decimal places. Will your estimate be more than John's answer or less than John's answer? Give a reason for your answer. Okay, so let's think about what we did to each of the things that we rounded. So we rounded volume up. We rounded the radius down. And we rounded pi down. So, because of the way that we've rounded things, when we get h on its own, so let's do a little bit of rearranging formulas too. So we know that v is pi r squared h over 3. Let's get h on its own. So if we multiply by 3, we get 3. V is equal to pi r squared h. And then to get h on its own, divide by pi r squared. So 3v over pi r squared is equal to h. So we rounded a volume up, so the top of this fraction for us is going to be bigger than it is for John, and we rounded pi and the radius down, so the bottom of our fraction is smaller than John's one will be. So we are dividing a bigger number by a smaller number. Our estimate will be greater than John's answer. Okay, question 16, some algebraic proof. So, with algebraic proof, never ever just substitute numbers in. Doesn't prove anything, only shows that it works or doesn't work for that value. So, n is an integer greater than 1. So that means a whole number bigger than 1. We want to prove algebraically that n squared minus 2 minus n minus 2 all squared is always an even number. Okay, so it's very common with algebraic proof that brackets will be involved. First move is to expand the brackets. So, n minus 2 squared means n minus 2 times n minus 2. Now, make sure from that you can get n squared minus 4n add 4. So, that means that we've now got n squared minus 2 minus that expansion. So minus brackets n squared minus 4n add 4. Now that minus on the outside of the brackets comes in and affects each term. So we're going to get n squared minus 2 minus n squared minus 4n. So that's add 4n and then minus 4. Now, what happens here is the n squareds cancel. So we've now got minus 2 add 4n minus 4. So that gives us 4n and then minus 2 minus 4 is minus 6. Now that can be factorized to 2 lots of 2n minus 3. Now, 2n minus 3 is always a whole number, so it's an integer. Remember, n itself is an integer, so 2 times an integer is always even. Cool. Okay, number 17, a bit of probability. So there are 9 counters in a bag, classic. 7 of the counters are green, 2 are blue. Rita takes a random 2 counters from the bag, work out the probability that she takes 1 counter of each colour. You must show your working. Okay, so they've given us a whole page of empty space that screams tree diagram. So, for the first part of the tree, well, we got green and blue. Now, there are 9 counters altogether, 7 are green. The probability of getting a green then is 7 out of 9. The probability of getting a blue is 2 out of 9. Now we need to be really careful here with our second branches, because what happens on the first affects the probabilities on the second. Okay, believe it or not, that is a B. Okay, so if there were 9 counters in a bag, Rita takes 1 out, there are 8 counters left in the bag. So each of these probabilities is something over 8. Okay, so going along the top, if she's taken 1 green out, that means there's 1 less green she can choose. So there's now 6 greens. So we got 6 out of 8. Now that simplifies to 3 quarters. Now that means then, well, there are still 2 blue. So that's 2 out of 8, which is 1 quarter. Or, if she takes a blue on her first choice, there's now 1 less blue. So the probability of getting a green is 7 out of 8. And now there's only 1 blue left in there. So the probability of getting a blue is now 1 out of 8. So there is our tree diagram. Now we want the probability of getting 1 counter of each colour. So let's find the paths that we're interested in. So we want either green and then blue, or blue and then green. Now, when you're working along branches of a tree diagram, you multiply the probabilities together. So the probability of green and then blue green and then blue is 7/9 times 1 quarter. Now, when you multiply probabilities together, you multiply the tops and multiply the bottoms. So this is going to give us 7 over 36. Now the probability of blue and then green, well, that's going to be 2/9 times 7/8. Now that on top gives us 2 times 7, which is 14. And on the bottom, 9 times 8 is 72. So that simplifies to 7 over 36. So the probability that we get 1 of each colour is these two, the 2 outcomes we are interested in, added together. So the probability of 1 of each. Now, they both have a common denominator of 36, so it's 7/36, add 736, which is 1436, which is 7 over 18. Cool. Okay, number 19, we got fun with equations of straight lines. So my playlist covering all of this is down below. So we have a rhombus ABCD. That means all the sides are the same length. That's a rhombus, it's a square. We're told the coordinates of A are 5 and 11. So let's write those on. We're also told the equation of the diagonal DB is y equals half x add 6. So that is the equation of that line connecting D and B. So the equation of that line is y is 1/2 x add 6. Now our mission is to find an equation of the diagonal AC. So AC is this line here. So connecting A and C together. Okay, so the key to this is the fact that diagonals of a rhombus meet at right angles. Now, that means these two lines are perpendicular. Now, when two lines are perpendicular, their gradients multiply together to -1. So, that means the gradient of dB times the gradient of AC is -1. Now, remember in y is equal to mx add c, m is the gradient. So we actually know the gradient of dB. And that is 1/2 because y is 1/2 x add 6. So the gradient of dB is 1/2. So we know 1/2 times the gradient of AC is -1. To cancel out a half, we multiply by 2. So the gradient of AC is equal to -2. So, at this point, we can now start filling in y equals mx add c for the line AC. So, AC is going to be of the form y is equal to -2x add c. Now we need to find the value of c. So the way that we do that is to use a pair of coordinates that we know lie on our line. So here that's the coordinates at point A. That's telling us when x is 5, y is 11. So we substitute those in. So when x is 5, y is equal to 11. So that tells us 11 is equal to minus 2 times 5 add c. So 11 is equal to minus 10 add c. Add 10, 21 is equal to c. So AB is on the line y is equal to minus 2x add 21. Cool. Okay, this one really is number 19. I can count. Okay, so O, A, B, C is a parallelogram. O to A is little a, and O to C is little c. So, by the way, it's vectors playlist down below. X is the midpoint of the line AC. So, let's stop there and put that on. So, the line AC is that guy there, and X is the midpoint of that, so that looks about there, and that is point X. Okay, next we are told that OCD is a straight line. So you might be thinking there's no point D. We're going to put one on. So because OCD is a straight line, that means we can go from O to C to D in a straight line. So that means that D is a point to the right of C. And it's also so that OC to CD is K to 1. So let's put point D on here somewhere. So what we're going to do is we're just going to extend this line out to a point D. So this is point D over here. Okay, and then we're told, given that x to D is 3c minus 1/2 a, we want to find the value of k. Okay, so we know that because OCD is a straight line, we know that C to D is just going to be some amount of little c, the vector c. Because the vector little c takes us from O to point C. We can continue on this straight line to get to point D. So what we need to do is we need to find the vector C to D. So that's our mission. Okay, so how are we going to do that? Well, we already know how to get from X to D. So we know how to get from there to there. Now, if we can work out how to get from O to X, we're then going to know a complete path that will get us from O to D. Now, when we know that, we can then subtract O to C, which is then going to leave us with the vector C to D. So, how can we get from O to X? Well, O to X we can do that by going from O to A, so along there, and then from A to X. So O to X is O to A, add A to X. Now we know that O to A is little a. Now we know that A to X, because X is the midpoint of AC, we know that A to X is half A to C. So we now need the vector A to C. So to get from A to C, we would go backwards along little a. So A to C is backwards along little a. So if you go backwards along vectors, you are doing the negative of that vector. So that's minus a, and then we're going forwards along little c. So it's minus a, add c. So that's the vector A to C. The vector A to X, we've already said, is half of A to C. So we now know that O to X is A, add 1/2 of minus A, add C. So that now gets us from O to X. Now let's expand and simplify. So this is A, then we got half times minus A, so that's minus half A, and then half times C gives us plus half C. So finally, O to X is 1/2 A, add 1/2 C. So that gets us from O to X. Now remember, what we're trying to do is work out the vector O to D. So now we can take this complete green path from O to A to X to C to D. So this path, O to D, is now O to X, add X to D. So O to D is O to X, add X to D. Now we know that this is half A add half C, and then add x to d. Now they give us that in the question. Let's add 3c minus half A. Okay, sure. Something nice happens here. The half A's cancel. So we got half A minus half A. So they go bye bye. So we are left with 1 half C add 3C. So that we could think of as 3.5 C, or probably simplest to think of it as 3.5 C. So we now know the vector that gets us from O to D. So this vector we now know is 3.5 C. Now, remember what we're trying to find is the length of the vector C to D. So, we can see that C to D is 3.5 C minus the C that gets us from O to C. So, C to D well, 3.5 C minus 1 C is 2.5 C. Okay, so we're so close now, we're almost there. So we can now say that O to C, over here, so O, we don't even need to think about vectors now, OC to CD, well it's in the ratio 1C to 2.5 C. Now we can divide both sides by C, so we get 1 to 2.5, but we're still not there because we want it in the form K to 1. So we now need to make the right hand side of this 1. Now to do this, we divide both sides by 2.5. So we get 1 over 2.5 to 1. Now then, for this fraction, 1 over 2.5, we don't really want to leave it like that because there's a decimal on the bottom. So we can multiply the top and bottom of this fraction by 2 to turn 2.5 into a whole number. So we get 2 over 5 to 1. So K is 2/5. Monster of a question, but we've done it. Cool. Okay, question 20, no funny business. Solve the simultaneous equations x squared and y squared is 25 and y minus 3x is equal to 13. So, quadratic simultaneous equations, lots more examples on this in my simultaneous equations playlist down below. Okay, so what's going on x squared add y squared equals 25. Hopefully you recognise that as the equation of a circle with a radius of 5, and y minus 3x is equal to 13 is a linear equation. It's a straight line. So the first thing that we need to do is rearrange the linear equation to get an expression for one letter in terms of the other. So looking at it, it's going to be much nicer to get y on its own. We're going to do that by adding 3x to both sides. So we are going to get y is equal to 3x add 13. Now, the aim of the game with simultaneous equations is always to get one equation in terms of just one letter. So, what we do with this is we use a method called substitution. So because we now know that y is 3 times x add 13, we substitute that into our quadratic equation. So the quadratic now becomes x squared add, when it was y squared, we now know though that y is 3x add 13. So we get x squared add 3x add 13 all squared is equal to 25. So we now have a quadratic purely in terms of x that we can solve to find the solutions for x. When we know those, we are then going to get the corresponding y coordinates. So, next move, expand those brackets. So, 3x add 13 squared means 3x add 13 times 3x add 13. So I'm going to use a table like that. So 3x 13, 3x 13. So 3x times 3x is 9x squared. 3x times 13 is 39x. And 13 times 13, Edexcel are horrible. That's 169. So that tells us then that 3x add 13 squared is 9x squared add 78x add 169. Okay, so back to the overall quadratic. So we've now got x squared add 9x squared add 78x add 169 is equal to 25. Okay, so now when you're solving quadratics, you always want to solve them equal to 0. So we're going to simplify the x squared terms. We're also going to subtract 25 from both sides. So x squared add 9x squared is 10x squared. So we got 10x squared add 78x, and then 169 minus 25 is 144. Now, at this point with these bad boys, it's always worth checking whether or not there's a common factor that we can divide away. Here, there is a common factor of 2. So we can divide everything through by 2. We're going to get 5x squared add 39x add 72 is equal to 0. So now we need to try and factorize this quadratic. So given that we got 5x squared, that even though it looks disgusting, that actually helps us. That tells us one bracket needs to have a 5x and the other has a single x. Okay, now we need two numbers that multiply together to give us 72. The x term and the number at the end are both positive. That tells us both numbers are going to be positive. So then it's really just a bit of trial and error. So whatever we put in the bracket on the right is going to multiply 5x. So that does make it a bit more complicated. So what multiplies together to give us 72? 1 and 72. That's not going to be any use. 2 and 36. Well, that's not going to be any use. 3 and 24. This is going to do it for us. So if we put 3 there, well, that's going to give us 3 times 5x, which is 15x. So if we then put 24 there, 24 times x is 24x, 24x add 15x gives us the 39x that we need. So we've factorized it. Now we need to get the solutions. So to do that, you set whatever is inside the bracket equal to 0 and solve for x. So x add 3 gives us a nice easy one. X is minus 3. And 5x add 24. Not so nice. So 5x add 24 is equal to 0. 5x is minus 24. Divide by 5. X is minus 24 over 5. Now that is minus 4.8. Don't believe me? I'm going to prove it to you. So this, let's use the bus stop. Minus 24 inside. 5 on the outside. So 5 into minus 2 doesn't go. Carry the minus 2. 5 into minus 24 go minus 4 times. So let's stick a minus at the front. Now we got a remainder of 4. We don't need to worry about the negative now, because we got the minus at the start. Carry the 4, put a point up the top. 5 into 40 go 8 times. So our two x solutions are x is minus 3 and x is minus 4.8. So, believe it or not, that's only half the answer. So, what we now need to do is work out the corresponding y values. So remember that we know y is 3x at 13. Well, when x is minus 3 then, y is minus 9 add 13. So minus 9 add 13 is positive 4. So one set of solutions is minus 3, 4, and then when x is minus 4.8. Edexcel are just horrible to us all the way through. 3 times minus 4.8, well, 3 times 4 is 12, 3 times 0.8 is 2.4, so that would give us altogether 14.4. We got negative though, so that's minus 14.4 add 13, so that's going to give us minus 1.4. So our second set of coordinates are minus 4.8 minus 1.4. Good times. Okay, question 21, bit of a strange one for 4 marks. So, ABCD is a quadrilateral. We're told that AB is equal to CD, which is shown to us with 2 dashes on each line. We are also told angle ABC is equal to angle BCD. So ABC is this angle. We can show that they're equal to BCD by putting little dashes. We want to prove that AC is equal to BD. So AC is that line there, and BD is this line here. So this is really a question about congruent triangles. Now there isn't much to do except state what's going on. So I'm going to pull out a sketch of each triangle. So there's B, C, D. And ABC. looks like that. So we're trying to prove that the two hypotenuse, or the two longest sides of each triangle, are equal. So this is basically an exercise in congruent triangles. So first thing we should point out maybe is that the angles are equal. So we should say that this angle is equal to that angle. So to keep length of a video down, I'm not going to write that, but we should say angle ABC is equal to angle BCD. We also know that AB is equal to CD, so we should say that, and we also know then that, well, BC is definitely equal to BC. It's a common side of both triangles. So by side angle side, ABC and BCD are congruent. Therefore, AC does indeed equal BD. Cool. Okay, number 22, final question. Oh, I've missed this question. It's, what is this doing in a GCSE paper? So the diagram shows a hexagon A, B, C, D, E, F. We are told that A, B, E, F and C, B, E, D are congruent parallelograms where A, B is equal to BC is equal to X. So let's put that on first of all. So AB is X and BC is also equal to X. Okay, then P is the point on AF and Q is the point on CD, such that BP is equal to PQ is equal to 10 centimeters. So that means BP and BQ are both 10 centimeters. Now they're not going to stay there for now. We don't need them yet. Okay, next up. Given that angle ABC is 30 degrees, show that cos of PBQ is equal to 1 minus 2 minus root 3 over 200 x squared. Good times. Where in the world do you start with this? Okay, so let's think about what we want to do. We want to show that cos of angle PBQ is this disgusting thing. So let's make a sketch of triangle PBQ. So, if this is PQ P and Q, we know these two sides are both 10. Now, they do give us a little bit of a clue as to what direction to take, because we want cos of PBQ. Now this is almost a non-right angled triangle in which we know, well, we know two of the sides. If we knew the third side, we could use the cosine rule to work out cos of the angle. Now, finding this other side of the triangle is actually going to be the first part of our mission. So, back to the overall diagram, we can make another triangle. So, triangle ABC. So, we are told angle ABC is 30 degrees. So that's all of this chap here. So, using the cosine rule, now for this I'm going to completely disregard the labels that we've got and stick my own on. The cosine rule is this guy, a squared is b squared add c squared minus 2bc cos of a. That's the form we're always taught it. That's why I've got rid of that b, because I'm now going to call this angle a, which makes this side little a. Now, side A, it's important to realise, is also the same length, PQ. It's the width of this whole shape. So, what we're also going to need to know here is one of our exact trig values, which I'm not going to go over how to work out here. After this paper, I'm going to make a brand new video explaining how to work these guys out. It's linked down below, check it out. So, we are going to need to know that cos of 30 is root 3 over 2. So again, if you don't know how to work these guys out, check out the video down below. It's a good time. Okay, so using everything then that we know then that a squared is equal to, well, our b and c are both x. So it's going to be x squared add x squared minus 2 times x, so minus 2x squared times cos of 30, which is root 3 over 2. Okay, so a squared is equal to 2x squared, now minus 2x squared times root 3 over 2. The two 2's cancel out, so this one here and this one here. So we then got minus x squared root 3. So, at this point, we can now say that a squared, so we can factorize this a tiny bit as a common factor of x squared. So we can say that a squared is x squared times 2 minus root 3. Now that's good, because in what we're trying to show, there is something that looks very much like that. So, if we actually wanted a, we would square root all of this. So we would say that a is the square root of x squared times 2 minus root 3. So, we are now done with this initial triangle A, B, C. Because down here, we now know that this length is root x squared times 2 minus root 3. So, what we're doing now, we are again using the cosine rule. So this time using the cosine rule, this is the angle that we want to take cos of P, B, Q. Now again, I'm sort of going to disregard the labels. So I'm going to think of this one as A, and then that makes this side A, and then both turns are the P and the C. So again, using the cosine rule, we know that A squared, which is x squared, times 2 minus root 3 is equal to b squared add c squared. So that's 10 squared add 10 squared. That's 100 add 100. That's 200. Minus 2 times b times c, so 2 times 10 times 10, that's 200. So minus 200 cos of p, b, q. So we now need to rearrange this attractive looking thing to make cos of PBQ the subject. So let's add 200 cos of PBQ to both sides. So we get 200 cos PBQ add x squared, what is that? Add x squared, lots of 2 minus root 3 is equal to 200. Okay, let's then subtract this term, so we get 200 cos P, P, Q is equal to 200 minus, now we're going to start writing it the way around that they've got it, so they've got x squared at the end. So 200 minus 2 minus root 3 times x squared, and then finally divide both sides through by 200. And we get cos BQ is equal to 200 divided by 200 is 1 minus 2 minus root 3x squared all over 200. Okay guys, that's the paper done. Remember you can find every higher Edexcel past paper walkthrough in one playlist down below. Hope you found it useful. Don't forget to give us a thumbs up, get subscribed, check out the content in the description. Good luck in your exams, take it easy, take care.